because this is kind of now leading outside the box. And we told you, we kind of kept you inside the box, saying group 1 is a +1, group 2 is a +2, transition metals, group 13 is a +3, and group 16, for example, -2, 17, -1. But we've kind of kept you inside the box. But now we're gonna move outside the box here a little bit. We're gonna deal with what we call oxidation numbers. This really comes into play when you saw some of our polyatomic ions and trying to figure out, well, why those charges don't always match up if you step back and think about it. Well, the charges of an atom would have, the oxidation number by definition of the charges in an atom would have electrons were completely transferred to a more electronegative atom in the bond. The relative charge of the atom, in other words. So rules to assign oxidation numbers. First of all, if you have a free element, or if you have a diatomic element or an element just by itself, it's free, therefore its oxidation state is 0. If you have a monoatomic, that's where again we have one of our cations or anions, just follow the charge of that cation or anion if it's by itself. Lithium's +1, therefore is a oxidation state of +1. Now the oxidation state of oxygen is in most compounds is a -2. However, with peroxide it actually is a -1. So remember, hydrogen peroxide is H2O2. Well, if hydrogen is a +1, I have 2 of them gives me a +2. My oxygen is added to -2. Well, in that situation, your oxygen is acting as a -1. All other times, though, it's -2. The oxidation state of hydrogen in a bond with a nonmetal is acting as a positive. That's where we saw it as a acid. It was a positive one. But when it bonded to a metal and when it's bonded to a metal like lithium hydride, then it's acting as a nonmetal and has a -1 charge. So it can be a +1 or -1 in that situation. The fluorine, the oxidation state is -1 in all compounds. However, the other halogens can be positive. So again, you kind of have to play this. That's where we start reaching outside the box a little bit. In a neutral compound, the sum of the charges of oxidation states mess that up to 0. In a polyatomic ion, the sum of the charges of the oxidation states, must add up to the charge of the actual ion. So we'll actually see that better as we continue on. So we see lithium hydride. Well, we know lithium is a +1, hydride is a -1. And so they come together 1-to-1 ratio. +1, -1 add up to 0. Neutral, there's no charge in the compound. My beryllium hydride we know is acting as a -1. I have 2 of them gives me -2. Therefore, my beryllium is a +2. It must add up to 0. There's no charge in the compound. On water, oxygen is a -2. Therefore, my hydrogen has to be a +1. There's +2, -2 adds up to 0. So hydrofluoric acid, hydrogen now acting as a cation. It's a +1. Fluoride is always a -1 in this situation. And this next one, fluoride is always a -1, gives me a -2. Therefore, my oxygen situation is acting as a +2. So unique. We have a little variety there. Focusing next on my hydrogen, my oxygen, is my -1. Actually, is my oxygen is a -2. Therefore, my hydrogen acts as a +1. And that's your hydrogen peroxide. That's one of your exceptions. Just understand, you always start with the anion. Always start with the negative here. Your chloride's a -1. Calcium, therefore, is a +2. My oxidation is a -2. So that gives me a total of -10. So my 2 chlorines must add up to a +10. Therefore, both of them are actually a +5. My Cl2O7, my oxygen is acting as a -2. So it's -14. So my 2 chlorines have to add up to 14. Therefore, they're 7 because they have to be neutral to each other. So we go through this whole process. As we get down to nitrate, we saw for the first time that, okay, my oxygen is a -2, gives me 3 of them, gives me -6. My overall charge of the compound is -1, so my positive and negative have to add up to -1. That's where my nitrogen becomes a +5. -6 gives me a -1. And so that's what I mean by, again, the charges of the oxidation states, the charges must add up to the charge of the compound. If neutral, they will be neutral. If there's a charge, they will equal that charge.